Good evening and welcome to Geopardy. Today's first contestant, the world-renowned physicist and Nobel Prize winning Dr. Strange.
Thank you.
Our next contestant is a geologist from Cambridge University, Professor X. And our third contestant, Steve.
Hey there.
Today's topic is rock dating. First up, last week's winner, Dr. Strange.
All right. Well, I think I want to go with northwest quarter, section 14, township 2 south, range 3 west.
When rocks form, observations of the rock's stratigraphy can be used to determine a rock's age relative to the rock's formation surrounding it. The layers observed form over immense geologic time and follow a set of principles that allow geologists to age the rocks. These observations follow many common sense concepts such as the law that states younger rock layers form above older rock layers, or the law that says sediments deposit in horizontal beds. Other principles include the concept that faults are younger than the rocks that they fault through, as the rocks had to be there in the first place for the fault to be made. The idea that formations of rock that look like they might have connected before probably did, as rock layers extend laterally in all directions, and the law that states rock fragments inclusions within another rock are older than the rock surrounding it. Professor X. That is not correct.
Well, you see, in order for any geology, you need to know the diameter of the Earth first, right? So this is the Earth. Bear with me. Here is America.
I'm sorry, that's incorrect. Steve.
Relative dating. What is relative dating?
That's correct. Point for Steve. Steve, since you got that question right, you get to choose the next topic.
I'll have the northeast quarter of the northwest quarter of section 14 of township 2 south, range 3 west. Is that okay?
Yes. These types of fossils are used to define certain periods of geological time. They are used in conjunction with relative dating to help determine the ages of rocks around them. They can come from a wide array of organisms, ranging in sizes from the very large to the microscopically small. Although they can come from a variety of environments, most of these fossils tend to be formed in an oceanic environment. Many of the animals from these oceanic environments tended to start their lives off as eggs or microscopic animals, which would be taken by oceanic currents throughout the world, which suggests their wide range. Some of the most famous examples of these fossils are trilobites and ammonites. Dr. Strange.
Well, you see, in my travels throughout Nepal, I know this answer. It's very simple, actually. You see, I'm going to complete my drawing, if that's all right. Here is Europe, right? And Africa.
I'm sorry, that's incorrect, Dr. Strange. Professor X?
Rocket.
That is also incorrect. Steve?
What are index fossils?
Another correct answer for Steve. Since you got that last answer correct, go ahead and choose another topic.
I'll have the northwest quarter of the northeast quarter of Section 14 of Township 2 South, Range 3 West.
Discovered in 1902 by Ernest Rutherford and often used alongside relative dating, this form of rock dating compares the abundance of a naturally occurring isotope within the material to the abundance of its decay products, which form at a known constant rate of decay, to provide a numerical calibration for the rock formations. The rock or mineral system must be closed, and the initial ratio of parent to daughter must be known to use this method. By allowing the establishment of geological timescales from this method of rock dating, it provides a significant source of information about the ages of fossils and the deduced rates of evolutionary change. Dr. Strange?
You see, as a world-renowned physicist, this is right up my alley, right? So I'm just going to finish this drawing again. Actually, I'm going to continue. What is minerals?
What is rock dating?
Both answers incorrect. Steve?
What is radiometric dating?
And 3 right answers for Steve. All right, for our next topic, Steve, go ahead and choose it.
I'll have the northeast quarter of Section 14 of Township 2 South, Range 3 West.
When clay is heated, microscopic iron particles within it acquire magnetism parallel to the Earth's magnetic field. They also point toward the location of the geographic North Pole at that moment. Once the clay cools, the iron particles maintain that magnetism until the clay is reheated. Using a dating method to obtain the age of rocks, it is possible to determine the location of the magnetic North Pole at the time this clay was last heated. Dr. Strange?
What is magnet?
That is incorrect. Professor X?
What is rock dating?
Also incorrect. Steve?
What is paleomagnetism?
And an astounding 4th right answer for Steve. Well, that takes us to our commercial break. We'll be back after these messages.